All right, so let's do this again. This is problem 5B now. So we've gone past 5A and we found out that the actual number there was 24 meters per second was the amount that they had sped up. This time around, it's asking how far would the automobile in question 5A have traveled from the starting line. So from the starting line is a good indication here that we are starting from rest. So that's a big deal here, which means that my starting velocity, right, is going to be equal to 0 meters per second. So that's my beginning velocity there. It doesn't tell us anything else because it assumed we've been looking at 5A. So let me go and write down a couple other things from 5A, making sure that we are aware of them. And one of those is that we have an acceleration, and the acceleration is 0.2 meters per second every second. So that's how much they're speeding up every second. It's 0.2 meters per second every second. And then we also know that we're doing this for a total amount of time of 2 minutes, which was 120 seconds. So this is the information that I've already gotten. And you'll notice that I just immediately started diving into this by drawing kind of the things that are my givens. Now, granted, I already drew my picture up above on 5A of just that little car that was traveling along. So I'm kind of jumping in here to my givens, but you could, of course, draw the picture of the car and say, hey, this car is here and it's going to be driving along. And what we're looking for here is a particular amount of distance, right, that we're looking for. We want to know how far has it gone. And so I often, again, draw these things down and put in the things that I know. So I've now drawn my unknown along with my picture. So I've got my givens here that I've written down, and I've drawn my picture, and I've got my unknown, the thing that I'm solving for. So this here is kind of my D, right, and my U when it comes to kind of solving these pieces. I need an equation in order to work this out. We only have 3 equations to choose from so far in this class. And so if this is the equation that we're looking for now, I need to have one that involves delta x and an acceleration and a delta t and things like that. So the only equation that I've got is this one here, which is a change in position is equal to 1/2 at squared plus vi times t. Got all these things, right? Do I need to make any alterations on this equation, or is it already solved for what I'm trying to get? Well, I'm trying to get this change in position, and it just so happens that it's already solved for a change in position, which means that I don't actually have to do any changes on this at all. It's already done. So my equation is set. So I am already ready for this substitute. So I'm getting pretty close here. So I'm going to substitute the things in that I already know. And let's go ahead and do that here. I'll do it in black. So I've got my change in position is equal to 1/2, right, times my acceleration, which is 0.2 meters per second squared. And then my time is this 120 seconds. So I'm going to put that in there, 120 seconds. Ooh, that's a really bad S. Try that again. Seconds. And that whole thing is squared plus my initial velocity, which it's the starting line. So I can write this in if I'd like to, meters per second, 0 meters per second. And then I'm going to multiply that again times, right, the amount of time. So I've got this. But we also recognize that this piece over here, 0 times anything is 0. So really this whole piece there kind of goes away. And the only thing that I have left to deal with when I'm solving it is the first part, which is just the 1/2 times 0.2 times 120 squared. So if we do this, I've got G, E, G, U, E, S, and I've got one more S to go, and that's solve. Now, this may or may not be something that you could do in your head. You'd have to know what 120 is squared, so maybe not. But it would just be 0.5 times 0.2 times 120 squared. So let's go ahead and write that down here to help us out. So I've got delta x equals, and I can do this part of it, right? So 1/2 times 0.2 is 0.1. So I know that's the case. And I still have the meters per second squared The second one is 120 squared. I'm going to go ahead and grab my calculator because this is a large number. So 120 squared is 120 times 120, right? And this number here is 14400. And the seconds are squared too, so I'm going to square the seconds. So these seconds are squared. Now, don't get confused. I've already done the squaring on this one here, so I don't have to re-square anything else. It just means that that squares on the seconds as well. And now here, this seconds down below cancel out, and this seconds over here cancel out because it's below and above. And all I'm left with is a 0.1 times this number here. And so my final solution to this is equal to delta x is equal to 0.1 times that, which is 1,440. What units do I get? Well, it's in meters, right? So my units are in meters there. So my meters are here. And this is what I've got. 1,440 meters is my final answer to that. This is just over, well, it's about 1.5 kilometers. 1,000 meters would be 1 kilometer. This is 1,500 would be 1.5 kilometers. So it's slightly less than 1.5 kilometers. But this, in the end, is my final solution that I was looking for here. And that, my friends, is the how far would the car have traveled, my delta x, after that amount of time. So I hope that helpful. Hopefully that is helpful. And if you've got questions, you're, of course, welcome to check in with me, and we'll talk through whatever you need. All right. Thanks, everyone.